Okay, I'm going to get started as people are still entering the room. Again, welcome to this web event being hosted by the Eastern Transportation Coalition. We're going to go through just a few housekeeping items. We are using Zoom webinar today. You can connect your audio through your computer or your phone, whichever works best for you. Please note this web meeting is being recorded. If you have questions about your audio or web, please reach out to Esther and she will help you. To ask questions, you're going to use the Q&A box. You're going to simply type your question in. We're going to keep track of those, and we have a Q&A session at the end. Some of the presenters may answer in the Q&A box during this event. If you have a question you'd like to ask verbally, there's a lot of people in this meeting, so we're going to mostly do our Q&A in the Q&A box. However, if there's something that can be better explained verbally, you can raise your hand. It'll push you to the top of the list and we will know that you have a question. At this point, first of all, I'd like to remind you the TSMO program director who helps coordinate all these events for the Eastern Transportation Coalition is Denise Marco. And today we have Stan Young, who is the Chief Data Officer at the Coalition, who is hosting the event. So at this point, I'm going to turn it over to Stan.
Thank you, Joanna. Let's go to the next slide. Denise couldn't make it today due to a schedule conflict, so I get to take her part. And for now, this slide is now a word from our sponsors. The TSMO branch of the Eastern Transportation Coalition hosts many events, and we just want to remind our members that these are the ones you can participate. These are things that have transpired in the past, a forum on ATSPMs, our highway operations group, the Transportation Data Marketplace, which is central to our discussion today and why we are here, as well as the RITIS, Regional Information, Integrated Transportation Information System, various opportunities to get involved and learn more. Let's go to the next slide. Those are the ones that have transpired. The upcoming events are shown here, various ones related again to the Transportation Data Marketplace, RITIS, and various other special topics. So if you're interested in any of these, just drop us a line and we'll get you connected appropriately. Let's go to the next slide. Thank you for joining us. We had over 260 folks registered from 30 states across DOTs, turnpikes, MPOs, federal agencies, universities, vendors, and consultants. Thank you for taking your time. We've prepared a venue today and tried to make it as organized and straightforward as possible for your benefit. Let's go to the next slide. I wanted to take just one slide to say how we got here. Why are we here? The Eastern Transportation Coalition hosts the Transportation Data Marketplace that has various offerings across numerous data categories. And one of those data categories is origin and destination data. Many states in the coalition are eager to investigate and apply OD data from the Transportation Data Marketplace. However, they are aware of this thing that FHWA has been investing in over the last few years called the NextGen NHTS. And those products are beginning to flow. So many of the states are inquiring what's available through this NextGen NHTS in comparison and contrast to the products that are available through the Transportation Data Marketplace. So that was the motivation, saying, hey, let's reach out and get a status update. So as a result, today's information exchange is on the status and use of NextGen NHTS products. Next slide. We've assembled an agenda here. The topics of the agenda, first, we're going to give you an overview of these products, the vision and objectives coming from FHWA. Next, from the University of Maryland, who's doing the work, you get to see what's going on behind the scenes. I sometimes call it sausage making. I know that I don't mean to belittle it, but there's a lot of data science that goes into that. And then switching over a little bit to the output, we're going to take a look at some visualization tools that are coming from Oak Ridge National Lab. And then finally, but not least, I think this is what everyone's looking forward to from the great state of Georgia with the state DOT and the MPO of Georgia, their first look at and use of this data, implementing it into several applications. And providing this information, let's go to the next slide. There will be a full bio provided for everybody, but these are our speakers. We're going to start off with Patrick Zhang from the Federal Highway Administration. Patrick oversees the whole program and will give you a good balanced look of what they envisioned several years ago when they started it and what they hope to provide to the U.S. and to the states. Followed by that, Michael Pack, the director of the University of Maryland CATT Lab, will let you know what's going on behind the scenes, how this is put together. I call it the good, the bad, and the ugly, but the process of combining multiple data sets into a reliable one for people to work with in this NextGen NHTS. Then from Oak Ridge National Labs, Dr. Wang will display some visualization tools that are accompanying all this data. Not only is Ross from Oak Ridge, he also spent a couple years down at the Florida DOT, and so has a link to the coalition. And then following bringing it all together, taking a look how this data is applied in the great state of Georgia, we got Habte Kassa from the Georgia DOT, who's overseeing how do we get this in, and he's partnering closely with the Atlanta Regional Commission with Rousseau, who's been actually putting it to use in models and in planning. With that, we'll get this underway and we'll turn it over to Patrick. So Patrick, if you want to go ahead and turn on your video and unmute your mic, you have the con.
All right. Well, thank you, Stan. Good morning, everyone. My name is Patrick Zhang. I'm with the Office of Highway Policy Information, Federal Highway Administration. Today, we're going to talk about our NextGen NHTS OD data product. Next. Here is a quick outline today. We are going to briefly talk about NHTS program, and then we're going to talk about the origin destination data product, and then we can quickly mention the add-on data product. Next. The NHTS program, we started in the late 60s. We periodically have a national survey provide tribal behavior data to support transportation policy and planning effort. And the survey taking place every 5 to 8 years. In 2018, Federal Highway launched NextGen NHTS, which take advantage of a new data source, such as passive data, and provide insight into long distance travel and have a biennial household travel survey design. The NextGen NHTS collect trip rate and OD data and provide a pool fund agency with shared research and data purchase opportunities. Next. The NextGen NHTS program has two data components. The core data has a biannual survey so-called focus on why, how, and when. And the OD data component focuses on where to where and its annual data product. Danny Jenkins for our office is the overall NHTS program manager, and I lead the OD data component. If you have any question about NextGen NHTS data product, please feel free to contact us. Next. We have both national and subnational origin destination data product. The national product include both truck and passenger OD data, and we have a contract with University of Maryland to deliver national OD data from 2020 to 2024. The subnational level OD data is for add-on partners. The add-on partner can purchase OD data up to block group level, and some state and NPO has signed up for the pool fund project, and we have delivered 2 add-on data products so far. And the add-on data product is for passenger data only. Next. We have predefined zones to produce the OD data. Our national product has 583 zones. Our zone basically is MSA based, and we have divided multi-state MSAs into state-specific zones, such as Kansas City, and some zones are from the remainder of the state, a total of 137 remainder state zones. Next. Next, please. Okay. Both national truck and passenger OD data product are annual data product cover all 50 states plus DC. Both product has 8 distance category, and the passenger OD data has 4 imputed tribal mood and 2 triple purpose. For add-on partner, for the add-on product, the trip count include annual, monthly, weekday/weekend, and the hour of day as well. And the coverage and the zone are agency defined, so agency can define any way they want to. And some agency also defined the distance categories. So when have more than 8 distance category, they can do so. We have 7 imputed tribal mode, and we have 4 trip purpose that's also imputed. We also have the demographics include age, gender, and income for the add-on data product. Next, please. The national truck and the passenger OD data product offer data file in the public domain for everyone to download. We have gone through 2 layers of independent quality control and the data validation. ISG perform the QA/QC within the contract, and Stacy led another layer of QA/QC for the data validation. We have a complete set of support document available to all users. That's also on our website. In addition, we have a web tool, which you're going to see in a few minutes, to create your own graphics and for your report. Next, please. The product status. We have released the 2020 OD data in June 2022 with online supporting tool and all the document. We have received 2021 OD data product deliverables, and we anticipate we're going to release 2021 OD data next 2 months. Next, please. Here is my contact information. Feel free, if you have any question, contact me, and our colleague will continue the presentation to give you a whole picture of our OD data product.
Cool. Thank you, Patrick. Excellent overview. I'm glad to see that every time you give it, it just refreshes everything in the mind. We do have one question about how the demographic data is brought in. We'll save that. I think Michael Pack will be commenting on that. So I have one last clarification for you. We can count on this NHTS for every year, the where to where going forward as a matter of product. I just want to confirm that. Well, I think we lost the audio for Patrick there. We'll get that confirmed.
Oh,
yeah.
Oh, okay. You want me to answer the question now? I thought that you want to answer at the end.
Okay.
Yes, that demographics was imputed too.
Okay.
Okay. Yeah.
Well, with that, we'll introduce Michael Pack as the director of the CATT lab. Michael's now in charge of processing the NHTS, the where to where data. And so, Michael, why don't you take it from here?
yeah, let's go on to the next slide. I'm gonna be focusing mainly on how this data is made. So you just saw Patrick present this slide, but I wanted to stress that I wanted to re-stress that there are really three classes of these next-gen data products. There's the national OD product, then there's the national truck OD product, there's the national passenger OD, which includes air, rail, vehicle, and other modes, and then there's what we call the add-on passenger data product, which has finer spatial granularity and includes additional modes and trip purposes. Now, there are slightly different methodologies and data used to create these three different products. And the rest of this presentation is going to cover at a high level how we do all of this. Next slide. Next. So we source this data from lots of different vendors. For example, truck data, it's going to come directly from telematics providers, from shipping companies that are aggregated by others and supplied to the University of Maryland. For passenger data, though, there are multiple data suppliers that comprise what we call our data panel. And all of these are location-based services type of data set. So it's not connected vehicles. And the reason we use this location-based data is like cell phone data is we really need multimodal data sets, and connected vehicle data doesn't usually have a persistent device ID other. And so, with this data, we can look at travel patterns for an entire year, and then we can produce all sorts of stats on different types of trips. Now, because we receive data from multiple vendors, one thing we have to be wary of is what we call deduplication, because we're observing movements over long periods of time. We identify home location, work location, active locations that the device goes to, and we're removing duplicate devices. And a lot of people ask about penetration rates. So regarding penetration rates, we have upwards of 80% of the entire population covered for an entire year, but we have to whittle that down to consistent sightings that we see, and it really averages out to about 16.1% coverage across the entire country. We can confidently say that we know home and work location for those 16.1%. But it comes out to like 270 million unique devices that we're looking at. And then, it does range between the different states. There are certain states that use different types of applications on their phones, or at least there's more prevalence of them that might have higher penetration rates than others. But we account for that a little bit later on. Next slide, please. So we have a pretty large process, a multi-step process that we go through to produce each of these data products. And the next few slides are going to go over each one of these at a high level. Next slide, please. So the first thing we do is we create sightings. So sightings are what is really like a ping of a device. It's not necessarily an entire trip. It's just we saw this device at this location. And the first thing we do is we evaluate all of these sightings, all these raw pings, and we want to make sure that there's nothing funny happening from week to week or month to month. So that could be like the loss of a data provider or something else going out of whack. So we're evaluating things like how many monthly active users are there, how many daily active users are there, and the regularity of all of this. So we also look at things from the data set like temporal consistency. So how often are these devices pinging? And when they're pinging, how accurate are the pings in terms of like their geolocation, like latitude and longitude? Is it plus or minus a couple of feet, a couple of inches, or tens of meters? Then we also look at the representativeness geographically of this. So is there variation in population coverage? Is it equally distributed based on the population of a region? And we might look at the device representativeness as well. So what are the variations in the daily sightings of a particular cell phone or mobile device. Some of the providers we get data from, they have a really low number of devices, but for those low number of devices, they're reporting very frequently, and other data providers have tons and tons and tons of devices, but they might only report, relatively infrequently. And so we're looking at all of that along with the active hours and daily coverage. And then after we've done that, we're looking at home and work location, and we use like a behavior-based model for that. So like, where are devices located at night? Where are they during the daytime? And we also do what's called deduplication. So there's a lot of duplicate data sets, duplicate devices that might be representative and represented in multiple data providers. And sometimes we join them together, sometimes we separate them and remove them. It just depends on what's going on. But if you're one of those people that has a cell phone and an iPad and a smartwatch with you all the time, they're all moving together, we try to account for that and remove some of the noise. Next slide, please. So this is the most complicated series of steps right here. It's surrounding tour identification and linking of trips together. So a tour is essentially a collection of trips that are strung together. For example, you might be going on some sort of a long distance trip, and you might stop for a little bit to get gas or grab lunch or something like that on your way to some sort of final destination. So we need to treat those types of trips and what a trip is differently than short distance trips. So if you're going like over 50 miles, for example, we consider that a long distance trip. And we have this recursive trip identification algorithm that goes in, and there's different thresholds that we have for stops based on time, speed, distance. And we do that for different classes of trips. But for a stop to become a primary destination, it must pass several rules, like stopping for more than 24 hours, and again, for like a long distance trip, or stopping for more than 2 hours plus intermediate trips that occur while you're there. It gets pretty complicated based on the trip type. For mode imputation, we're using trip trajectory information like travel times, speeds, information about the transportation network itself. So, is there a rail line or a bus line or something like that? For air trips, it's really all about a mix of the speed of the trip and the start and ending of the location. Like, do they start at an airport? Do they end at another airport? For rail, we have data sources that tell us where rail stations are and the routes. For buses, we have bus route and stop data, and it helps us identify where trips can be bus related. And then when we are identifying the worker type, which is the next thing we have to do, there are different types and classes of workers. So there's people who work in fixed locations, right? You drive someplace, you work there. There's also like professional workers, like drivers, like taxi, Uber, delivery drivers, that sort of stuff, and workers that move about. And so, we need to know that so we can understand the type of trips that they're taking. And we want to exclude things like taxi drivers, but we don't want to exclude the passengers of the taxi drivers. And then we have all sorts of different trip distance calculations. For rail trips, it's based on the transit network. For an air trip, it's the distance between the airports. And, there's different rules for different types of trip types. And then the most important thing really is, at the end of this, we have to be able to account for biases and the fact that we're only seeing a certain number of all the trips that are out there. So we have this multi-level weighting and data expansion series of steps that we do. First, we really have only a sample of these devices, so we weight them to be representative of the entire population. We're imputing socio-demographic information like age and income, and this helps address some of those biases. But then we take into account biases in the trips themselves. So what types of trips are being taken? For example, you we're probably not observing all the trips from a device, right? So the baseline has for figuring out what types of trips there are has usually been the past NHTS surveys that have happened. And so we use that to try to then create this multi-level weighting and data expansion. Next, please. After we've done all of this, we've essentially now created a national trip roster, and it is time for us to then go in and validate the data that we've produced. And there's 6 different types of validation we do internally, but we also have external folks, other companies that come in and look at the data set. We do all sorts of reasonable checks as well. So for example, we don't want to see a driving trip that went from California to Hawaii. That's not possible, right? Or crazy trip rates between zones that just don't make any sense. Or trips from DC to California that have a distance of 100 miles, that doesn't make any sense. So we're doing all sorts of reasonable checks and this other types of validation. If we see something that's wrong, we then might go back and recalibrate, revalidate, rerun some of the stuff. And so this is really very much a cycle that we're going through with validating this several times. And essentially that is how the national OD product is created. Next, please. Now there's also add-on products that exist. So that's where you can go in, like a region like Georgia or a metro region can go in and request more specific location data for packaging the results into zones or custom zones that they might have. And it's very much the same general methodology, except we do enhanced travel mode imputation. So we're looking at biking and walking trips, and we're dividing those out. We're looking at more bus related data. And then we're also looking at enhanced trip purpose imputation. So it's home to work, home to other, work to other, and then other to other types of trips. And instead of just looking nationally, we also do monthly ODs for the add-on product. And some folks also have us do holiday ODs, and that's excluded with the national product. And there's other socio-demographic imputation that we do as well. Next, please. For validation, it's really the same process that we had before, except when we're validating local products that have more fine-grained information in it, we often use local data for the validation. So that could be local travel surveys, local traffic volumes, not just the HPMS, and other mode specific surveys that an agency might have. Next slide. So you're going to hear about this a little bit more later, but Georgia is one of the pooled fund add-on groups that has requested data from their region. They've got 7,441 census block groups, plus these halo counties and surrounding zones. They'll talk more about that a little bit later. Next slide, please. And then the last product is the truck OD file creation and its methodology. And it's a lot of the same processing as before for ingesting data, but the trip weighting and linking are really different. And one of the things is the trips IDs are mostly the same. We're able to follow trucks for long distances. The trip weighting is a little bit differently. So passenger trips have home locations, but trucks, we don't have the same thing for them. So we treat that a little bit differently. But for the most part, it's the same general process. Next, please. So there are some caveats that we like to talk about on the use of the data. The biggest one is that this is truly an OD product. There's no trip path information. So if you're trying to look at cut through trips, that's not something you can do with this data set. Holiday trips are excluded for the national product. The data itself, even though it's at fairly large zones for the OD, it's still a big data product, and it could be an issue for some people to download it and use it. But there are tools that have been created that help with this. And you're going to see a presentation from ORNL in a few minutes that will talk about some of that. A tour is really defined as a home-based tour, departing from and arriving at the home location of the device. Therefore, the total number of tours is always 0 for OD pairs with different origin and destination zones. Next, please. We've done a lot to deal with privacy protection for OD pairs, but privacy protection also means that we sometimes exclude trips that have, a certain limited number of trips moving back and forth from different areas. And for the 2020 national OD product, there was balancing that we did. And there's more information on this in some of our documents and our methodology as to why we did this, but just notice that all the trips are balanced. And then the pooled fund OD data product can be calibrated and validated according to the available local ground truth data. I already talked about that with the ARC example, the Georgia example, and that does help with the local products. Last slide, I believe. Next. So when it comes to getting access to this data, you want to go to ORNL. They're about to present on how to get access to the data, how to download it and work with it. There's other tools as well. You all are familiar with the RITIS platform. We do have a TRIPS analytics product that can ingest this data as well, but ORNL is where you want to go to really download and get first access to the data set. Next. So if there's any additional information that you want, you can reach out to myself or Patrick, and we'll start to go through the questions and we'll try to type out answers to them as we progress. Thank you.
Thank you, Michael. Appreciate that overview. And Ross, why don't you get ready to share your material? Michael, I'll note there's several questions, and the questions having to do with fidelity of the data, whether with respect to sociodemographics or to spatial areas. So look at those and we'll come back at the end and maybe you can address them verbally. I do have one question before you go. At TRB, as well as with the Transportation Data Marketplace, we've been exposed to issues, what I call data supply chains, due to changes in policy, either at Google or Apple, or changes in state regulations. Some of this data supply chain gets disrupted. With that in mind, how vulnerable is this NHTS moving forward as far as consistency and availability, in your opinion?
Data comes and goes all the time. You'll see press releases, things in the New York Times, Washington Post about data being misused and vendors essentially going out of business because of privacy concerns and all sorts of other stuff. There's even impending legislation that might disrupt some of the access to these data sets. What we try to do is have a large panel of data providers so that we're not dependent on any one particular vendor, so that if we lose one, we've still got enough data from others that we can be statistically confident in the products that we're putting out. But there are concerns, long-term concerns, about a large chunk of this data potentially disappearing if there's certain legislation that's passed. We can't do anything about that, but we do have plenty of other methods to help prevent dramatic implications from the loss of like just one provider.
Okay. Thank you very much. We're going to come back to the end with more questions, definitely, particularly on fidelity and how do we trust this. But next, we want to get Ross in front of you. Ross has some demonstrations of what's available, particularly at these national data sets. So Ross, you have the con.
Thank you, Stan. Can everybody see my slide, my title slide? I'm sharing NextGen NHTS OD data product tools.
Yes, we can see it. Thank you, Ross.
Thank you. I see a question. I'll answer that quick. NHTS stands for National Household Travel Survey. So during my part, I'll be talking a little bit about the tools that we developed for Federal Highway, in the sense, as Michael talked about, that the data could be large and not everyone is, having the capability or bandwidth to wrestle with the raw data. So we are at ORNL provide some tools that can help you get the data and get a visualization that could be helpful for your reporting or presentation purposes. So I will dive in. So this would, I'll be doing a live demo, but I would just want to show a few slides that will give some general information. So this is the website. We will provide the link at the end. Also, it will be in the slides that will be provided, but we'll have basically some high-level overview, visualization of the data, and some links for documentation and data downloads. Before I dive into the live demo, I just want to touch on the recommended settings for using the tool, because this is a web-based tool. We recommend using modern browsers, Chrome, Firefox, Edge, and so on. We do not support Internet Explorer anymore. The display settings, we recommend to set it to be 1920 times 1080, and the orientation is landscape with the scale at 100%. So a lot of the laptops may default to 125% or 150%. It's better to change that to 100% for better, for easier use of the tool. Now I will switch over to the website. I'm showing the website.
Yes, we're seeing the website.
Okay, thank you for confirming that. So as I said, this is the landing page. You will have basically some description of the data set. And again, ORNL is a long-term team member of the NHTS data program. So we've been hosting the National Household Travel Survey, the core data, as well as right now the OD data. When you get to the front page, you will have the navigation bar on the top, and then some high-level visualization on the bottom. And I will get into some of the details. So this is the home. If you go to downloads, this is where you can download the data. Now the data comes in different settings. You can download the whole passenger data, including the data file, as well as the data dictionary in a zip file format. So this will be the link you use. And same thing for truck data, and then the shapefile. So the shapefile is what Patrick has shown earlier in his presentation, where there are 583 zones that are being defined by Federal Highway for the OD product. Or if you want to wrestle with the raw data without downloading the zip file, you can do the data file itself, and then the data dictionary. We do have some recommended citation that you can use if you're using this data. In the documentation tab, we provide further information on how to get started with the tools. So this is kind of what I'm going through right now. And also in the slides that will be shared later, there will be some of the information that is from the quick start guide. And then we have the technical release, as well as the data methodology, so that these are the detailed documentation that basically was covered by Michael earlier. but this is more details and more information that you can find in those reports. We have some frequently asked questions, how the zones are defined, how the trips are estimated. So these are the high-level answers that may answer some of the questions that you have in the Q&A. And here is a video tutorial that tells you how to basically use the tool. And then we have two different types of tools. One we call it summary tool. The other is analytics tool. So the summary tool is basically give you a way to quickly summarize the data. So on the left-hand side, you have the selection panel. You can select data component by either passenger or truck. So I'm going to just randomly use an example. You can select the geographic area and the summary type. Right now, we selected Alaska but let's say you're from Atlanta. You're interested in learning about the truck trips that coming into Atlanta, going out to Atlanta, as well as the truck trips within Atlanta. This is a quick way you could get a summary table for that. Now, if you see the columns, we have inbound, which are the trips that are coming into Atlanta zone. Where outbound would be the trips that generated from Atlanta going out, and then within. This is summarized by distance, and truck data, as Patrick mentioned earlier, has the distance category. So the 8 categories are shown here. The table here can be downloaded as a CSV file. So what you're seeing here, you can actually click download CSV, and then you can play with that, do your own visualization using that CSV file. You can also, we have provided some visualization options here, so you can do heat map. What that means is basically a color, give different shades to the cells. So the larger trips are having darker shades, and you can also do, for example, bar charts. And you can summarize the data based on the total trips, for example, where you can also summarize by the percent of columns. So that gives you some information and opportunities to quickly visualize the data. And all the visualization that we are generating here can be downloaded as a PNG file. For example, you can just click here, that will download a PNG file. And I'll go back to here. And then same thing, for example, you can do a Sankey diagram and other type of visualization. So I encourage people to play with it and give us a question if you, contact us if you have any questions. We could also do passenger data, for example. In passenger data, we have a little bit more attributes. The truck data only had distance, but for passenger, we do have mode, purpose, and the distance and mode can be a two-dimensional data, distance and purpose, but there's no purpose and mode. If you're looking for that, that is not provided in this specific data set. So for example, we want to look at distance and mode, then basically the data is summarized by distance and mode. Each of them have the values. And again, these data can be downloaded as a CSV file. Another feature that we're providing from the summary tool are the mapping options. So we have 3 different mapping options. One is called the top OD flows. In a sense, this gives you the top however many, you can go from 100 to 1,000 flow records, flow like pairs that you can visualize the data. So I'll use a quick example. Say I want to look at the top 200 air traffic and visualizing a map. I can do that by sliding that to 200 or 212 in this case, and this generates a map that gives you some options to first look at it. There are some legends here on the top you can see. You can download this as a PNG file. You can also, again, download the data for you to visualize it by yourself or for other purpose, for reporting purposes. So let's say, and this can be further, there are some interactive options we can do. So for example, if you click on Atlanta, you can select among the top 212 trip pairs, how many of them are from Atlanta, right? So this gives you some option to then visualize, for example, you are working with the Atlanta airport and you want to see what are the top destination from your airport, then this would be a good use of that map. We do have origin and destination flow map, so I will use this as example, and I will use, for example, vehicle trips, and say you want to look at state level instead of the zone level, right? So, for example, here in the state of Texas, you want to look at where are the high trip rates that goes to the destination states. So you can use this map to then know this is from Texas to say to New Mexico and so on and so forth. So you can see that, because this is vehicle trips, so the trips that are having higher darker colors of the choropleth map is the surrounding states. So this is a quick summary of what the summary tool can do. I'll switch over to the analytics tool. So what previously you saw in the summary tool basically assumes the origin and destination are at the same geographic level, right? So they're both either at zone level or state level. For the analytics tool, we provide a little bit more flexibility in the sense you can select a zone. So for example, I will use Atlanta as an example. So you can type in, if you know the zone name, you can just type in the search box. So I'll give you an example. For example, I want to see the trips from Atlanta to all the zones in Georgia, right? So in this case, I would select Georgia. And notice there's an aggregate button here. So if you click aggregate, what that does is basically sums everything up to the state level. But in this case, I don't want to aggregate because I want to see the trips that are originating from Atlanta to all the zones in Georgia, not just the state level, but zone level. So this is how I selected. So in this case, you can just click run and you can see predominantly the trip are within the Atlanta region. So you want to actually exclude the intra-zonal trips. And this gives you a visualization. Again, you can download, in this case, PNG or PDF file. And in another example, if I want to, I'm in the state of Georgia, I want to see all of my zones in Georgia, what are the OD look like? So in that case, I would select from all zones in Georgia. In this case, I'll just select state level without aggregating the data, and I can increase the number to 1,000 again. We can then run this, and this gives you more information about the zones, the OD flows. So this is what we call the core diagram. Another diagram we can use is we call it OD matrix. In a sense, we have the origin, have the destination, right? So in this case, the origins are the x-axis, the destination and y-axis. If you hover over, you will see the number of trips that are between those zones. Note that I excluded the intrazonal trip, right? So if I don't exclude it, the color will be predominantly across the diagonal lines. All these data, what you're seeing used for visualization, are also provided as a table format here, as you can see. So, and this gives you a little bit more information because previously the visualization only tells you the zone IDs. So if you're not familiar with the data, you may not what zone ID, which zone ID means which zone. So this gives you a reference. You can come and check. And then I'll give one last example. There's the state hexagon map. That basically is a way to visualize state level information, and this is actually one-to-many to show one-to-many relationship. So in this case, I have from national, so the total national anywhere in the country to all the states, right? So if I run that, I'll have basically from the nation to California, the trip is and this many. For the visualization, then this is what you can see. Right now, we're only looking at the total trips. We could also do vehicle trips, which then gives you slightly different information, but still California is predominantly the trips, the highest trip, right? But then you can actually exclude intrastate trips, then you'll see that with interstate trips, then these states actually have higher trips. Same thing we can do, for example, air trips, and then if you run it again, and this is the results. And all of this visualization can be downloaded as a PNG or PDF file. So this is pretty much all I have, Stan. I don't know if we have time for questions or if you want to save that for later, but thank you all for the attention.
Thank you, Ross. That was quite an extensive presentation. So we're so glad to not only get the portal to download the data, but the first step in to begin to visualize it. Very excellent. I do note that you're with the Oak Ridge National Lab, and I spend a lot of time with the National Lab here in Golden. At some point in time, we got to get energy data associated with this. So I'll plant that seed and leave it later for discussion. But we want to get on to our last presenters. Our last presenters, I think this is, I know I'm very eager to hear this. It's putting this data to work. A lot of folks are eager not only for the national data, but to say, what if we get this for our own specific state or region? To address that, one of the first ones out of the gate is the Atlanta region, and we have Habte and we have Guy to present to us on their first experience on getting Georgia specific data. With that, Habte and Guy, why don't you take the con and bring us home?
Thank you so much. Good morning, everyone. My name is Habte Kassa with the Georgia Department of Transportation. I'm going to be tag teaming with Guy Rousseau from Atlanta Regional Commission to share our experience using the NHTS NextGen audit data as Stan said. Next slide, please. So as you can see on this slide, Georgia DOT has been a long-time partner with the National Household Travel Survey Pool Fund Program. GDOT purchased 7,000 households add-on in 2009. And again, in 2017, we purchased 8,000 household completed surveys. Under the NextGen NHTS, GDOT and ARC jointly committed again for next generation NHTS core data, basically the survey, and also purchased the 2020 passenger body data product add-on and has plans for purchasing an add-on sample to the 2024 core data survey effort. So I know Mike addresses as NHTS 2020 data, but we purchased the 2019 data because of the pandemic. So GDOT has been using NHTS data sets in various projects and programs, including travel demand modeling and regional and corridor level studies. But today's presentation is focusing on the 2019 audit data that we purchased. So the NHTS 2019 is, as Michael and others said, it's a passively collected location-based service data. And it provides information about trips, the number of trips, persons, some demographic details because we're on an add-on, and then the audit data has been tailored using GDOT's request on top of the national audit data set, like Michael was referring in this presentation. Next slide, please. So, with all the attributes that I just talked about in the 2019 audit data, there are several ways to utilize these data sets into various types of, GDOT's transportation planning programs, projects, as I said. It's all via travel demand model. First, we have to develop the model and we use it in the model. In Georgia, we have a statewide model that we call it GSTDM. It covers the entire 48 states, but the focus is on Georgia and also the neighboring states. And Atlanta Regional Commission also that they have activity-based model, and we also use it for other 14 MPO models. We do have smaller MPOs outside of ARC, Atlanta Regional Commission, and Chattanooga for the remainder of 14 MPOs GDAT develops and maintains the data, I mean their model. So the next generation NHTS data reflects 2019, which is the pre-pandemic condition. GDAT will use this data set for calibration and validation, while at the same time trying to reflect the impacts on travel patterns that was caused by the pandemic. Next slide, please. So, model inputs, model input update and model calibration is, it's basically an iterative process, or, those who are, modelers know what I'm talking about. First, a set of, model inputs are, prepared for each of the models, whether it's for the Georgia State Travel Demand model or the 14 MPO models that I talked about, the regional, usually like county or a couple county. Once the input files are ready for model run, then the input files will be adjusted based on the model run outputs and calibration statistics that came out of the model. The GSTDM, which is the Georgia State Travel Demand model, has a freight and the passenger model. It has two different modules, the freight and the passenger. For the passenger model, the number of trip attractions equations will be estimated again using the 2019 OD data set, because all of our models, whether that's the GSTDM or the 14 MPO models, because of the pandemic, again, we made a decision to make 2019 as a base year. So that's how they are going to be validated and calibrated. The internal and external trip share at external stations will also be calculated using the OD data set. Major trips, origin destinations, will be identified using the OD data set for the calibration step. And then in the model input side of it, the rates, the share of the trips, works as an input to the travel demand model. In the calibration step, again, the output is to cross-check to see if it really matches with the data input. And then in the calibration process is mostly, backtracking whether the model works properly with the provided inputs. For example, if the inputs model shows, 48% non-home-based trips, then the calibration should match that. If not, the necessary adjustment will be, done afterwards. Next slide, please. So, NHTS, provides, auto, rail, and air trip splits, as Michael said in the beginning. The model input for, mode choice can be checked against the 2019 OD data, basically. All of that will be checked into the, input data development. Next slide, please. So once the model, input is prepared and ready, then the output will be created using the travel demand model, whether it's the GSTDM or the 14 regional models. The model trip tables will be compared with different slices of the NHTS. There is a lot of slices. The model calibration is again an iterative process, as I said in the beginning. And then based on the model outputs, the model input and the coefficients will be changed to match it. The number of trips, the percent share of the trip purpose, whether it's home-based, other, non-home-based or others, the trip flow by trip purpose, all of this will be calibrated using the origin destination data. Major origins and destinations based on the OD data again, they produce and attract a lot of trips, because they are major attractions and destinations. They work as special generators for, the passenger trip, for example. We do that for the freight too, but I'm focusing on the passenger. Those specific areas or counties will be calibrated again based on the OD data. The short and long trip percentage will be compared to match with the OD data. I know, Michael in the beginning said, like, if it's 50 miles, there is a different category. In our first iteration of the GSTDM, we started doing 50 minutes as a long trip, but we convert that into 50 miles instead of by time we kind of change it into a distance to kind of categorize whether it's a long distance or a short distance. So basically less than 50 miles will be like a short trip. Internal and external or internal external trip percentages, all of distributions will be compared with the OD data. And then in the Georgia Statewide Travel Demand Model, auto, transit, and air trip will be matched with the OD data again because it has a lot of those components. Next slide, please. So, I talked about we have 14 MPO models that we do travel demand model. It's kind of similar steps. The MPO models are urban or urbanized area, however terminology that you want to use. With a greater sub area and the county details, because a lot of our smaller MPOs are either single county or at the latest, at the most. Maybe a couple counties. There are a couple counties, a couple MPOs that go beyond the state border, but we got the idea. We have either, for the most part, single county or a couple counties. The MPO model, covers greater details, which is designed to reflect the unique and specific characteristic. Remember, we are developing the model. GDOT is developing the model for MPOs for the federally required, MTP, Metropolitan Transportation Plan. So. Basically we try to kind of characterize it based on the trip making characteristics on the area. For example, the Savannah MPO, the coastal region MPO, is tailored to reflect the travel and the freight flow pattern from Savannah region because of the port, Savannah port in that area. So the NHTS data will be specifically looked at for the region to understand if the model is, specifically reflecting the travel pattern of the specific region in this case, like the Savannah region. So pretty much the same scenario, the same kind of procedure. The MPO travel demand model input files preparation is kind of similar to the GSCDM. The only difference I can mention is just a couple of them. The attraction coefficients are estimated for the whole MPO area instead of urban and rural split, because as I said, they are either a single county or a couple counties. The trip production and attraction will also be adjusted by area type. We have a lookup table for 7 different area types from CBD all the way to rural. So the MPO model have a component too much with specific area types, as I said, 7 of them with a lookup table. So basically, the NHTS data will be used to calibrate the trip production and attraction by trip purpose, and then the block group OD data. That's the geographic level that the OD data comes can be aggregated to the MPO region, county, whatever area that we would like to do for cyber extraction or anything else. So basically, the aggregated OD data will provide a reliable source to observe trip flow by purpose. Next slide, please. So again, MPO models are auto and transit trips. They will be compared to the 2019 OD data flow for auto and transit. This is applicable when transit option is present in the specific MPO. For example, we have a couple, maybe 3 MPOs that have significant transit trips like Savannah, to some extent, Macon and also Athens. They have transit, and so we apply those. Next slide, please. So, it talks about, again, the MPO model calibration, nothing really specific to talk about. It's the same process that I talked about when we do the calibration for the GSTDM. The only thing that I would like to mention probably is the major origin and destination produce and attracts a lot of trips. They work as special generator, again, as I was talking about in the past, in the earlier slide rather. And then, we just do the calibration to match with the OD data. with that, I don't want to take a whole lot of time. I'm handing it over to Guy for the more exciting part of the presentation. Guy?
All right, thank you, Habte. So let's go to the next slide for a deep dive. We're going to take a deep dive into this quote unquote big data set that is specific to the Atlanta region and also the state of Georgia. So just a brief
You seem to frozen.
Yeah, next slide. Oh, okay, thank you. Yes, so this is the actual, again, think of it, this is the add-on data set, the local add-on OD data set. This is our zone structure, similar to what Echo showed us earlier. So we have almost 7,500 census block group levels, which again is tremendous. And then the halo area and then the surrounding national partial zones and the national zones. So next slide. Thank you. So in terms of data analytics, there's a couple of ways to handle that. We take all the CSVs, we take those into RStudio, but we also do some GIS analysis. Here's an MXD of the geodatabase for exploring the zones that's specifically to the state of Georgia, but then we take a deep dive into the Atlanta region. And again, on the right-hand side, it's just another way to represent the actual zonal structure and geography of the data set. Next slide. Okay, and now here is the, this is a work that's in progress. I want to thank and acknowledge my colleagues, Michael Peck, and also Greg Jordan at the UMD CATT Lab with us. We're all familiar with the trip analytics aspect of it. This is a way to accommodate this big data. So this is the actual NextGen NHTS origin destination trip analytics component. I'm showing an example here of two counties in the Atlanta region. The upper left county is Cobb County. We're looking at liberally color-coded. Those are the census block groups. So those are basically our traffic analysis zones for trial demand model at ARC, active-based trial demand model. And then the right-hand side in the bluish color scheme is the CATT County. And so on this graphic picture, we're looking at origin destinations, county to county movement. And then we're looking at a 2019 data that answers the question that came up earlier and have to mention it. This is 2019. The reason is to get a good overview of pre-pandemic travel traffic conditions. But the beauty of this data set here again is that it's at the monthly level. And so soon we will get 2020 for January and February, which are also pre-pandemic. And then later on, we'll get a post-pandemic data set so we can literally look at both aspects of it. Next slide. And then this slide here, that's again the same thing, but it gives you a better idea of the actual of what we're looking at. So initially, just very randomly for the demo for today, we selected 7 counties. Counties are small. The Atlanta region are in the state of Georgia. In the Atlanta region, we have 21 counties in our trial demand model. It sounds like a lot, but again, counties are small in Georgia. I'll get to it in a second. And the actual origin definitions, ODs for, so it's internal, the Georgia zone, and external. And then we added filters. That's what we're showing here from Cobb County to the CATT County. So script that started in that Cobb County, that ended in the CATT County. The filter, so the filter here, we're looking at December of 2019. Other filters that we've applied, we're looking at the actual weekdays. For trial demand modeling, we'll focus on the usual weekday workday, Monday through Friday, although for weekend models and other types that data sets available for weekend. But for this example, it's the weekdays, and we look at car travel. We could look at other modes, but we're looking at car travel. Next slide. So this next slide basically shows us other ways to handle this types of big data analytics as part of this platform, trip trip analytics. So you can see on the left-hand side here, the different filters and queries that we can apply to the data. Again, there's a lot of flexibility built into it that allows us to perform all types of data analytics for model development, model applications, and model calibration and validation. And we'll go to the next slide. So here's a brief overview, preliminary draft, very draft rough, I would say conclusions, findings from the data. So in terms of data structure, those are CSV files. We'll get one annual data file and then 12 monthly data files. So month 1 to 6, then month 7 to 12. And just to give you an order of magnitude of, I mean, this is when we say big data, it's really big, right? So for the case of Georgia, the file size, it's a 10 gigabyte table. And then once it's all unzipped, literally we're looking at 35 gigabyte worth of data, or the equivalent of 15 million records. So again, it's a very large data set. Forget about Excel, that cannot handle it. That's why we take everything to RStudio, as well as some ArcGIS applications. And then we've also looked at the trips that are linked, origin, destinations. And then, so we noticed something, and we're about 1 million of those records, about 8% roughly. Some are marked with a privacy protection flag, and which is super helpful for model development, because obviously we do not want to fabricate microdata with this. We got to protect the privacy of the individuals and the population. So basically what we're looking at here is anytime we have a number that's less than 5 trips, that is redacted as a -9, and that's just the way the data file is reported. So we usually filter out those -9 values because obviously we want to preserve privacy. And so a value of -9 is the minimum level of origin destination flow, because we also have cases where there's actual 0 values. You got to be able to tell the difference between a true 0 value and a -9 for this personally identifiable information filter. Very helpful and useful. Let's go to the next slide. And we've done some very broad overall review type of analyses. So one example here, looking at the number of counties with 0 interstate trips for specific modes. So in this case, looking at the county as an origin, then the county as a destination, travel mode, air, rail, bus, and bike, and then the number of counties. And so now keep in mind, again, we have 159 counties in Georgia. They're fairly small, which is really, quite frankly, helpful for data analytics. The smaller, the better, right? So this is just an example. We do this for quality assurance, quality control of the data, and reasonableness checks, in addition to the ones performed by Michael and the staff that he presented earlier. Let's go to the next slide. And on the next slide, this is actually, those are trips by imputed travel mode. Again, similar type of a brief general overview, looking at percentage of trips by mode, and then percent of trips by mode, obviously car, and then some obviously walk trips in bus, air, rail, and bike. Again, we're still going through sorting out this quality control, but so far it looks pretty good. And let's go to the next slide, where we look at thank you. So trips by distance, and we're doing that for trip length frequency distribution, TLFD, we're doing parallel modeling. So, but keep in mind here, another aspect is the trip distance bins. So we saw earlier with Ross' presentation, 0 to 10 miles for the national data set. But when you do a local add-on, 0 to 10, that would include the bulk of the trips, right, in the region. So we have smaller bins here, which is very, very helpful for parallel modeling. So again, this is the beauty of this data set, where it's very flexible. It allowed us to get smaller trip distance bins. It's something we requested, and it's looking good so far. Now let's go to the next slide, which is, I believe, the last one for, thank you. So for just overall conclusions and findings. So there's a count field that allows all kinds of QC and troubleshooting, looking at origins and destinations. And then we did some random checks throughout the data. So the zone containing the busiest airport in the world, the Atlanta International Airport, and it is rightfully one the commonly listed as a destination zone. And then followed by Birmingham, Alabama. The reason is because all the trips are more or less funnels that are going west out of Georgia to the Birmingham region for reporting purposes. So that's also making sense. Now the NextGen NHTS add-on, this is obviously passive OD data that's been collected, that's explained earlier. In my opinion, is a very rich and very large data set. Here we get the best of all worlds, right? Because this is a data aggregation process performed at UMD. So they aggregate data from different vendors. So you don't only get just one, you get all of them aggregated into one single unified data set, which is what we need for problem model calibration and validation. But that's only one aspect, one part of the equation. The second part is the actual more traditional local add-on household travel survey, which we will be doing in Atlanta in 2024. And again, other findings, obviously you need RStudio is the best tool to handle these types of large big data OD data set. When you get that CSV file, it's also feasible to spatially join and attach it in GIS to create a geodatabase for additional mapping of the data. And the last item here is really, this is very important. This is a pool funding effort. The collaboration between our state DOTs, so GDOT and NARC, but other MPOs, other DOTs should probably do the same. It's a very good way to leverage limited funding, limited resources, whether it's a state DOT level or an MPO level, to get very rich and robust data set for model development. And that is the last slide. So thank you. I'll turn it over to Johanna or Stan for final Q&A.
Thank you to all our panelists. Even though I was busy watching the question and answer, I caught as much as I can and very much appreciate this top level view all the way down to its application. I'm going to start the Q&A and thanks for everyone to keeping in their time limits. We have about 10 minutes left, so I don't have a lot of time, but a good majority of the questions were very detailed, so I trust the presenters will answer those specifically. A few of the questions, about a half a dozen, all had to do with validity and quality of the data, whether that's representative across sociodemographics or whether it varies with spatial aggregation, various things like that. So I'm gonna open it up to the panel, and if all our panelists could turn on their camera and unmute their mic as appropriate, and give you one question. You've all had opportunity to work with this. And this is somewhat of a selfish question because our group at the Eastern Transportation Coalition is charged with validating various vendor data in this category. So tell me your number one concern in the quality region, as broad as possible, in working with this data that states and MPOs and others should be mindful of with respect to its quality or accuracy. And with that, if we could just go around the horn, everyone on the panels had got to touch it and work with it, so you probably all observe things or have particular concerns. So who wants to go first? Guy, you're still on, so
yeah, I'll go first. So that's a great question. One of my primary concern, and it's not an issue at all whatsoever, it's the make sure we protect the privacy of individuals and the population. That's why we have these filters that allowed us to remove some where we have very small, very low numbers where you could fabricate over micro data sets. So we filter those out, they're redacted. So that especially when you work with the public or in an MPO or you do traffic forecasts, you want to make sure that there's no way to fabricate what I call micro data sets. So that's the beauty of this data.
Okay. Do any of our other speakers want to come back on and unmute their mic and address that?
I don't have any concerns, Stan. Thank you, though.
Well, that's strong, strong endorsement. I want to put Patrick. You're the overall lead. You must be asked this a few times over and over.
Okay, yeah. The one, if I have any concern is the data coverage. You know, the data coverage does not have the same density as well, as Mike showed in his presentation, some area has a much more data coverage than others. And this is something we are working on to, have, when you dealing with a large country like what we have work on, it's just the data density just change pretty dramatically from one place to another.
Yeah, I'll concur with that. And there's a lot of things we do to try to account for changes in penetration rates, which then impacts device and trip level biases and weightings. That's one of the harder things that we have to deal with. And there's never a way to be perfect, but it's I think we've got a pretty decent methodology that we have spent a lot of time on.
I'm going to move on with a few more questions because, I was expecting to hear, hey, be careful about age bias because these smartphones are known to have a bias with respect to age distribution, but I'm not hearing that. So I'll let that one sit. The next question, we have not only a what we call LBS based NHTS, we also have a biennial survey. How is that moving forward? We didn't spend a whole lot of time on that today, particularly in detail, but that is one of the late questions that came in, and I recognize that we didn't address it in detail, but would someone like to say where that is at with respect to the overall program and how?
Okay. I can say a few words. The biennial survey data have a totally different focus. We have talked about it in our presentation. And so far, the data collection for 2020, I think it's 2020, is completed. We are wrap up the survey, and hopefully we will release the data pretty soon. Danny will tell you more. If you do have any particular question, contact us. Danny is in charge of that data product.
Danny has his hand raised. We can unmute if you'd like him to respond.
That would be great.
Okay, can you hear me now?
We can.
Okay, we have just completed the data collection phase of the 2022 household survey, which encompasses 7,500 households all around the country. We've started the process of processing and weighting that data. We hope to have public data sets available late spring, early summer of this year. So stay tuned for that. So that's really the current status on the household survey component.
Thank you, Danny. Thank you, Danny. I know there's a ton of questions I would like to ask about where could this go from here, but I'll hold off. Part of this data, I think it really came of age through the pandemic while we were scrambling to try to get an idea of how the pandemic was impacting the mobility and the behavior, and many of those data sets that were just emerging got pushed to the forefront. So we look forward. I hope we don't have another pandemic, but should we have this data being an asset and being ready to be put to use should it happen. Is there any final thoughts? We got 5 minutes left. Go around to the panelists and any parting thoughts to our members as we go off, starting with you, Patrick.
All right. Well, our goal is to deliver the data, the best quality data on time. That's our goal. There's some challenges once a while, and like our 2021 data, we are still trying to get it out, but I think we resolve all the issues. It's going to come out soon. in the next year, we will have this back into a very good track. We'll get the data on time and with good quality, people can trust. That's our goal.
Thank you, Patrick. And I'll be knocking on your door and say, hey, when can we get energy integrated into this too? Going on to Michael Pack, what's your thoughts there? Final thoughts.
Final thoughts are, the data is only useful if people are using it. So go check out the ORNL website, which we've typed in the chat, and download it and play around with it and give us your feedback.
Great. Ross, I was texting Ross in the background. I learned a new word today, chloropleph, basically meaning color-coded map. But Ross, do you have any last thoughts for our audience?
Oh yeah, just tag along what Michael was saying. The tools are only useful if you're using it. So I encourage people to use the tool and play with it. And also kind of, I think Patrick might have touched this, but we have a newer version of the OD data that will be coming out soon. So be on the lookout for the next next version of the data that will be integrated with the tool as well.
Is that 2021?
So we have 2021 is not approved yet. So that's but the data is in review process, right, Patrick?
Yeah, we're working to release 2021. I believe it's come out pretty soon, very soon. We are getting to the final stage now.
And lastly, Habte and Guy, I think your email inbox will probably be buzzing the next few weeks, if not a few months, on other people trying to follow your path. So any last parting thoughts?
I see that. Thank you, Stan, for this opportunity. I just want to say that we've been pretty good at using taxpayers' money. And we, as I said in the presentation, we started using the NHTS data back in 2009. It helped us significantly to develop our statewide travel demand model. And then we added again, we came back and joined again the program in 2017. This time we focused for the 14 MPO original models that we, GDAT develops, and it helped us to get good triplets. Believe it or not, the previous survey was done 20-something years ago in Savannah, in Augusta, Georgia, rather. And then it was just a big assumption was made. Savannah, Augusta is an MPO. Whatever happened in Augusta, it happens in all 14 MPOs. That was not the case. It took us all the time to develop and to calibrate the model. It took us a long time, but the 2017 surveys helped us significantly. And now, we're joined again. Our hope was to get the 2020 core survey, but because of the pandemic, we had to put off, but we could join the OD data we're getting, and that's what we presented today. And we're looking forward for the 2024, the core data. So we are really a constant clients of this program, and we're very thankful with that.
Thank you, Habte. Guy, any last comments or thoughts before we bring this to a close?
Yeah, thanks, Stan and Coalition, for the opportunity to make this presentation. So again, I invite everyone to take a deep dive into your own respective data set, and especially if you go with the local add-on origin destination data, you get the best of all worlds, right? In my opinion, you get the best of all data vendors that are feeding into this, and you get one aggregated data set thanks to the data aggregation methods at UND CATT Labs. I want to thank Michael Pack and his staff and Greg and everybody else that's working with the trip analytics component to ingest this very large data set and make it more user-friendly for all of us, because it's nice to do stuff in our studio and GIS, but I like this additional tool here, so I look forward to more collaborative efforts with the group.
One last shout out to our panel for having such excellent presentations and being so well prepared. Again, thank you. And with that, Joanna, I'll turn it over to you to close this out.
Thank you, Stan. Again, and I reiterate that. Thank you to our panelists and to Stan for hosting. Of course, to the Eastern Transportation Coalition. We are going to keep the Q&A box open. So if you have any last minute questions you think of, please add them in. Panelists, if you'd like to review them, if there's anything else you'd like to add, please do so. Please note that the recording of this event as well as the Q&A summary with all the questions will be provided in links to everybody who's participated. So that does take a little bit of time, but as we'll follow up with our speakers and make sure they have an opportunity to review the Q&A before it gets all sent out or posted to the coalition's website. So again, at this point, we are just thanking you for your participation, and please look forward and go to the coalition's website to look for additional events that are happening in the next couple of months. Thank you.